I'm back again. The last video you watched should have ended with the screen that you're seeing right here. Nope, other way. Right here. Ooh, look, I'm learning how to do things. If you see this, you should have watched that video first. All right. So next video moves us on. Okay. And it's asking you, what's the intercepted arc for angle FOG? What's the intercepted arc for ABC? I'm starting here with this one because this leads into our next video and the next set of rules. So even though it was on the same page as the other one, I paused where I did on purpose. So this says, what's the intercepted arc for angle FOG? Now, how do you decide that? Well, angle FOG is right here. And if I think of this angle as an alligator, yes, I know it's childish, but if I think of it as an alligator, the intercepted arc is what the alligator is eating. So the intercepted arc for FOG is just the arc in between the endpoints of the angle. So it would be FG, piece of cake. So what's the intercepted arc for ABC? Even if I covered up the circle, and I know I can't cover it up here. Ooh, you know what? I can do it right now. Even if I covered up the circle, if I wanted the intercepted arc for angle ABC, it's going to be AC because the endpoints of that angle are A and C. Now let's see if I'm right. So if I look at angle ABC, where is it? Angle ABC is out here. What's the intercepted arc for that? This is num-numming right here, and it's eating AC. And then it says, what's the intercepted arc or arcs for ABD? Well, if I look at ABD and look at the fact that I have this optional plural here, ABD is this alligator, and it has teeth that go all the way back. So technically, it has two arcs in its mouth. It has this one that it's well on its way to swallowing, but it also has this one. So there are two intercepted arcs for that one, and it would be arc AGD and arc AC. And last but not least, what's the intercepted arc for EC? Angles don't just have intercepted arc, chords do too. So if I erase this and I look at EC, EC is this chord right here. The intercepted arc for EC is arc EC, which, you know, makes a lot of sense. But it's also the arc on the back side, arc EGC. So technically a chord can have two intercepted arcs, and it really always has two intercepted arcs, one that's a major arc and one that's a minor arc, or maybe two semicircles. All right. Now, why do I care about that? Well, I care about that because we start using those intercepted arcs and angles to find measurements, to find values for things. And if I were not teaching this in crisis mode, I would have you explore these things, but we don't have that kind of time. So we are going to learn some rules about arcs and angles. You need to memorize these. They're not bad, but you do need to memorize them, all right? So the central angle theorem. It's the theorem about central angles. So if you look at this circle here on the left, this is angle A. The measure of angle A is equal to the measure of the arc that it's eating. Now, let's think about that for a second and why that is what it is. If I went all the way around and back, this would be 360 degrees, right? If I took that circle and I went all the way around and back, that circle would also have 360 degrees. So it makes sense that the two things should have the same measurement. So long story short, if you have a central angle, that central angle and the arc are equal. So over here we have an 85-degree angle. That 85-degree angle is eating an 85-degree arc. That's it. Now, compare that to the inscribed angle theorem. The inscribed angle theorem says that the inscribed angle is half the intercepted arc. So if my angle touches the edge, it's smaller than the arc by a factor of 2. Okay, so if I came back here and I said this is 62, that means that 62 is half of the arc that it's eating. That 62 is eating this arc PQ, so that arc would be 124. 62 times 2 is 124. Okay. And then if I said, well, then what about angle POQ? Well, POQ touches the center. That's a central angle. So the central angle has to be equal to the arc. So that would also have to be 124. So the inscribed angles are half the arc. Central angles are equal to the arc. Now, inscribed angles can be anywhere on the edge they want. So this angle A, this alligator, is eating this arc. But this angle A is also eating that arc. So guess what? They have the same measure. So inscribed angles, since they can touch the edge anywhere they want, you often have inscribed angles that are equal because they're eating the same arc. So if we come over here to the next one, this 72 is eating this arc. So that arc is twice 72, which would make it 144. There's another inscribed angle that's also eating that 144, and it's WYX. So WYX would be half of that 144, making it 72 as well. So notice, both of these have to be equal because they're both eating that 144. Okay, so those are both 72 because 72 is half of 144. And then it says, what's arc WX? It's 144. Okay, and we have that 38 in there. I might as well talk about it. This 38 is eating, if I extend it, is eating VY. That 38 touches the edge, so VY is twice the angle. The arc is twice the angle is half the arc. So 38 times 2 is 76, which means this angle W back here is also 38 because it's half of 76. All right. And then last but not least, I've got cyclic quadrilaterals. Now, this is one that in the scheme of things, not incredibly important because you can find your way around it, but a cyclic quadrilateral is any four-sided shape where the four corners touch the edge of the circle. Okay, so all four angles touch the edge of the circle. The rule about cyclic quadrilaterals is if you have a quadrilateral inscribed within a circle, the opposite angles are supplementary. They add up to 180. Okay, so A and C would add to 180, as would B and D. They would also add to 180. So if I come over here to this one, here's a quadrilateral that's inscribed in this circle, okay? This quadrilateral is inscribed in the circle. So 69 and the angle across from it have to add to 180. So 180 take away 69 is 111. So that's 111 degrees. Okay. Now, why do they have to add to 180? Because if I come back over here to this one and I look at A and C, C is eating this side of the circle. A is eating that side of the circle, which means A and C together are adding the whole circle, which is 360 degrees, but they're inscribed angles. So inscribed angles eating 360 degrees would total up to 180 degrees because the inscribed angles are half the arcs. Okay? All right. So we have these exercises down here, and I'm going to do those in another video. All right. So pause this here, go get a drink, or just move on, and we will see each other soon. Stopping. Wish there was a stop button that was closer, but there's not.